Hello students, our study today is about exponential graph. First of all, let me start graphing by y equal x plus e power minus x defined on R. So we start by doing limit at minus infinity. So if you replace here by minus infinity, you're going to get minus infinity plus e power minus infinity, so infinity. And I know that exponential is stronger, so the answer must be plus infinity. But since we have minus infinity plus infinity, the rules say we must put the strongest in factor. The strongest is e minus x. So we divide here by e minus x when we put in factor. Here by e minus x and here by e minus x, you're going to get this one. Now we do Hospital's rule because this is infinity over infinity. This is 1, and the derivative here, you derive the power and you put it before minus e minus x plus 1. So a number over infinity 0. 0 plus 1 is 1 times infinity, so infinity. And now if you do limit at infinity, e power minus infinity is 0. 0 plus infinity is infinity. Now I'm asking you that prove that y equal to x is an oblique asymptote at infinity. So we do f of x minus x. What is left is e minus x. E power minus infinity 0. So y equal to x is horizontal asymptote. Now time is for derivative. Derivative of x is 1. Derivative of e power minus x. You derive the power, it's minus e minus x. Since here it's positive and here you have minus in between, we can solve it. However, if you had 1 plus e minus x, it's always positive, 1 plus. But since you have 1 minus, so we equate it to 0. We put 1 to the other side, you have e minus x equal to 1. So you introduce then on both sides, or you can say minus x equal then 1, which is 0 directly. So x is 0. So you have the 0, you have minus infinity plus infinity. If you take a number bigger than 0, for example, if you take 1, if you replace it here in y prime, here y prime, okay, if you take more than 0, you can take 1. You can realize in calculator this is positive, here negative, going down up. And if you replace here by 0, you're going to get 0 plus e power 0, 1. Here this is 1. So let me put 1. So now if you want to graph, here you have y equal to x, horizontal asymptote, oblique, so it's coming here and going up, horizontal asymptote to y equal to x. To graph y equal to x, you need to take 2 points. If x is 0, y is 0. If x is 1, y is 1. So this is the oblique. And 0, 1, this is 0, 1. It's coming from up, as you can see, going to the minimum and going oblique asymptote to the function. Now we want to graph f of x equal ex over x. You cannot have x down because it will be a vertical asymptote. So domain is r minus 0. So we start by doing limit at infinity of infinity over infinity. So Hospital's rule. Derivative of ex is 1. Derivative of x is 1. It's infinity. Minus infinity. E power minus infinity is 0. 0 over minus infinity 0. So here we have y equal to 0 horizontal, and we do limit as x tends to 0. E power 0 is 1, a number over 0 plus or minus infinity. So x equal to 0 vertical asymptote. Now we need to do derivative of the form u over v. U prime is ex times x minus derivative of x is 1 ex. Always when you have exponential, you put exponential in factor. So equal to 0, you don't take exponential because it's always positive. So x minus 1 equal to 0, so x is 1. Here, first of all, don't forget that 0 is a vertical asymptote. You do it as hashed. And you have the 1, which is a max or min. You put 0. You take a number bigger than 1. Let us take 2. Replace it here. It's positive, and before it's negative. So negative going down, and going up. At minus infinity, if you look here, you have y equal to 0 horizontal asymptote. Vertical asymptote 0, it's a plus. Down minus, here it's a plus. This is a plus, not minus. And at infinity, you have infinity. Now you have the 1 left. If you replace here by 1, you're going to get e power 1 over 1, which is e. So now how the curve looks like. Here you have y equal to 0 horizontal. It comes from horizontal to x equal to 0 down. You can see it here. And then coming from up to the minimum and then going up. As you can see it here, this is the minimum, which is 1 and e. This is 1e coming from up to the minimum and going back up. Now we want to graph f of x equal x plus 1 e power minus x. From minus infinity, I want it from minus infinity till infinity. So first of all, we do limit at infinity. Infinity times 0. لأنه e power minus infinity is 0. Always when you have infinity times 0, we do Hospital's rule. We keep x plus 1 up and you take e minus x down, ex down. Now you have infinity over infinity, you do Hospital's rule. Derivative of x plus 1 is 1, of ex is ex, a number over infinity is 0. So we have y equal to 0 horizontal asymptote. And if you do minus infinity, here you have minus infinity, and e power minus infinity, it will be infinity. So you have minus infinity. If you do the derivative, this is of the 4, u times v, so this is u, and this is v. Derivative of u prime, this is 1 e minus x. Derivative of e minus x, it's minus e minus x into x plus 1. So if you expand, now if you expand, you're going to get e minus x, e minus x, minus e minus x. These two cancel out. You're left with minus x, e minus x. Always we don't take exponential because it's always positive when you equate to 0. So minus x, e minus x equal to 0, so x is 0. We put the 0 here. You take a number bigger than 0, 1. If you replace it, sorry, here, minus 1, e minus x, it's negative. Here, positive. Going up, then down. At minus infinity, you have minus infinity. This is minus. And at plus infinity, you have y equal to 0. And if you replace x by 0 here, you have 0 plus 1 is 1. So it's coming from down to the maximum here that you have, and then going to y equal to 0 horizontal asymptote. Now we want to graph f of x equal 15 times 0.4 minus x, e minus x plus 6. You have 0 close till infinity. I want it from 0 close till infinity, so we do only limit as x tends to infinity. So here you have minus infinity times e power minus infinity 0 and plus 6. Plus 6 is does not interfere with the 0 times infinity. So you put it aside. So we know that infinity times 0 is 0 and plus 6. So the limit must be 6 at infinity. But we need to do it Hospital's rule because we have infinity times 0. So what we do, you will keep this up and you take this down. If you have a problem with the 15 times 0.4 minus x, you can multiply inside by 15. 15 times 0.4 is 6 minus 15x. So now you can work of this in this one. This is the same. And instead you can have here 6 minus 15x over ex. So derivative of 6 minus 15x is minus 15. 15. Ex is ex, and plus 6 plus 6. A number over infinity here. 0 plus 6 is 6, so y equal to 6 is a horizontal asymptote. And if you do the derivative, if you have problem with that one, you can use this one. So derivative of 6 minus 15x is minus 15 into e minus x. Derivative of e minus x is minus e minus x into 6 minus 15. You can put exponential in factor. Always you put exponential. See, here you have minus 15, here you have minus 6, and you have minus times minus plus 15x, so you have minus 21 plus 15x. If you equate it to 0, you have x equal 1.4. So here we have 1.4. f of 0 you replace here in calculator, you're going to get 12. 1.4 you replace in calculator, you're going to get 2.3. And you remember that at plus infinity you have y equal to 6 horizontal asymptote. So the curve comes from 0, 12, here 0, 12. This is y equal to 6. Y equal to 6 here. 1.4 down you have 1.4 and 2.3. This is 2, 2.3. So the curve is coming from up, going to the minimum, and going to y equal to 6 horizontal asymptote, as you can see. Now we have f of x equal x plus 1 plus e power minus x plus 1. So first of all, we do a limit at plus infinity. So this is infinity plus 1 plus 0 infinity. Now I want to ask you, show that y equal x plus 1 is an oblique asymptote. You do f of x minus x plus 1. You're left with e power minus x plus 1, e power minus infinity 0. Now if you do the derivative, it's 1 minus e power x plus 1. If you equate it to 0,